Hey everyone, Ronak this side. I hope you all are doing well. So let's jump into the today's problem. So what today's problem is state is check if array is good. So and what good means you are given an integer nouns. We consider an array good if it is a permutation of base n. So I mean it's an arrangement of base n, and basically arrangement doesn't matter here. It can be any arrangement of that base n. And what base n means? Base n basically means you have a series of that n number and then again n. I mean basically base of base of 3 means series of 1, 2, and 3. I mean the number, I mean the size, and again the maximum element. I mean again the 3. Base of 2 means 1, 2, and again repeat the last element. Base of 1 means 1 and again repeat the last element. So basically a good array is can be the permutation of any base n. So it is a 3 comma 3 comma 2 comma is it a good array? Yes, it is, because it is a permutation of base n. Okay, so it's I mean I think it's one of the easiest problems, so let's encounter it. So basically what we're gonna do is we're gonna create an array of frequency. I mean let's we're gonna create an array of frequency of the same size in the array nouns given. Vector vector int frequency of size nums dot size, and fill everyone with 0 initially. So now what we're gonna do, we just gonna iterate over array. I mean let's, for example, we have given an array 1 comma 3 comma 2. So how to check if it's a good array or not? So basically we just gonna iterate over here via an auto loop. Auto x in nums, and for every num x, we what we gonna do, we just gonna increase that index by 1, because here x is plus plus, and we just gonna increase this. And one more important thing to check, I mean let's consider a int n equal to nums dot size minus 1. I mean this basically represent the total number of indexes. We have 0, 1, 2, 3. Okay, so one thing to notice, if any element x is greater than the n, I mean the number of index that nums has, this can't be a permutation. So what we just gonna do is, if any x is less than 1, I mean it cannot be 0 also, or it is x is greater than n, then we just simply return the false and just do the frequency plus. And how do we check the frequency? For let's consider we do a frequency plus for this array. So the frequency array becomes the size is basically 4, same as the nums. So the frequency of x can basically 1 become 1, 3 become 1, and then 3 become 1, I mean 2. It's basically little and 2 double 1, I mean just tally mark you can 2, and then 2 become 1. So what we're gonna do, we just gonna iterate over this frequency, and if any of this is not equal to 1, we just return false, because all of the elements should be 1 except this. We don't care about this because we iterated this many times, the all should become 1. So for and I equal to 1, I less than equal to what is been less than nums n, here value of n here is, and here is nums dot size 4 minus 3. Okay, so we just gonna iterate over 1, 2. So it's basically less than n and just I plus plus. And if any of the frequency at index I become not equal to 1, we just return false. And if all code runs perfectly, we didn't return false, so simply just return true. Okay, so this is the total code. So let's try on for another example. I mean, what can be the base of 4? It 1, 2, 3, 4, and again 4. So now permute it in any order: 4, comma 3, comma 2, comma 4, comma 1, order better. Now let's try run this. So what we have here is frequency of size 5. 1, 2, 3, 4, and 5. So first what gonna happen is, first in the I axis this, so we're gonna increase index at 4 by 1. Again in I come x become this, so increase index at 2, and x doesn't go 0 or exceed the boundary limit, I mean 4. I mean it doesn't go beyond 4. I mean it does never become 5. Okay, and here is okay, yeah, 1, 2, 3, 4, 5, and here equal to 4 nums minus 1. Okay, so it never gonna exceed 4. And now when I goes to mean x becomes 2, it just increase index at 2, I become 4, increase index at 4, I become 1, increase index in 1. And now for this loop, we're starting from here, I equal to 1, frequency of I is not equal to 1, false. Again increase frequency of not equal to 1, frequency of not equal to 1. Nah, so we have to iterate, and here n is 4, so we just have to iterate 1 comma 2 comma 3. We iterated over 1 comma 2 comma 3. Now this loop is over. Now simply just return true. Okay, now let's code this and see if it's working fine or not. So what we wanna do first, take int equal to nums dot size minus 1, and the frequency vector int frequency of same size as the nums, so we are given all filled with 0. Now we just have to iterate over nums for auto x nums, and the simple condition here we are checking if x is less than 1 or x is greater than n, simply return false. I mean it can be one return false, either just frequency of x, just increase the frequency at x index by 1. And now check if any we got any incorrect frequency. So starting from int I equal to 1 and moving till less than n, we are not checking the last index of frequency, and doing the I plus plus. Now just if any frequency at any index not equal to 1, just return false. Okay, oh, what the hell, I mean just return false if any of this not equal to 1. And if all loop over and we found no defect, just return true. Okay, so let's run the code for first time and see if working. And now let's submit the code and see if all test case pass. Okay, so we got a perfectly fine code, we just submitted it. And now if we have to analyze the time complexity, we are iterating over nums, and both have approximately the same size, so it's almost big, or I mean time complexity is also big O of n, and this also big O of n, so overall time complexity is become just big O of n. That's the time complexity. And space complexity we are using here is also big O of n, because we are taking an array of frequency of that size. Okay, so that's basically the time complexity in space. This is a very easy problem, so let's give it a go. I hope you like this video. Please leave a like and make sure to subscribe to TENZOR and turn on the notification bell for more such interesting content. Also, feel free to ask doubts and comment. I'll try to reply every possible comments. See you tomorrow. Till then, keep smiling, keep coding.